Hello, Honors Chemistry, and welcome to Chapter 5, where we start talking about molecules and compounds, and specifically in Chapter 5, we learn how to write the formulas and write the proper names for a great number of chemical compounds, actually. So what cool skills you will have by the end of this unit. So anyway, for starters, things to know. So we talked about in the previous chapter that what differentiates a compound from an element, right, is that we take two elements, right? So here we have sodium and here we have chlorine, right? Both of which are poisonous by themselves, right? Sodium, if you ate it, you would die, right? Chlorine, if you ate it, again, you would die, right? But when we put them together, right, we get something quite tasty and necessary in small quantities to our survival, right? So clearly that is, again, going back to compounds versus mixtures specifically, right? In a mixture, everybody retains their physical properties, right, and chemical properties. Whereas once we combine them into a new chemical compound, right, so now in sodium chloride, my sodium is chemically bonded to my chlorine, right, specifically there is an exchange of electrons to form a cation and an anion, and during that process, the properties change, so that way now we get this one new thing called sodium chloride that has its own unique set of properties, right, which again, essential to life. Okay, next up, let's talk about mass versus particle relationships and how to read and write formulas, some basics. And this should harken back to things you already know from middle school. So, first of all, if we have a formula like this, which is propane, right, this tells us that we have 3 carbon, right, so 3 atoms of carbon for every 8 atoms of hydrogen in one molecule of C3H8. Yes, does that make sense? So there are 3 atoms of carbon, 8 atoms of hydrogen in every one molecule of C3H8. Oh, does anybody sense conversion factors that we will tease out of here later? Yes, we will. But no worries, we'll come back to that later. But those are the relationships that are present there, right? Likewise, what we could also say is that since we know, based on our periodic table, that 3 atoms of carbon have a mass of 48.03 grams of carbon for every 8.08 grams of hydrogen, yes? For every, so let's add that up. So then what that says, right, so that also translates as there are 48.03 grams of carbon for every 8.08 grams of hydrogen, right, both of which correspond to 56.11 grams of C3H8. Yes, does that make sense, right? Just putting together how we can look at things from the particle relationship, right, versus mass relationship, yes? Every sample of propane abides by these respective ratios for mass and particles. Yes, does that make sense? All right, so switching it up and talking about some of these other compounds here, right? So we got this, right, which you'll be able to name as manganese perchlorate soon, manganese 2 perchlorate specifically, right? So we have 1, and here, we'll clean that up later, 1 ion of manganese, right? 2 ions of ClO4. Yes, does that make sense, right? This 2 extends to everything inside of those parentheses, yes? Which means that if we were to break this down further, we could say that there are 2 chlorines and 8 oxygen in every one of these. Yes, does that make sense? Right? Likewise here in this one, right? This says we have 2 NH4s, right? 1 SO4, right? Do you see that? In that there's no parentheses here, right? And that's one thing. We'll clarify later why you should know that's SO4 and not 1S versus 4 O's, right? And here, this is 1 aluminum, right, versus every 3 bromine for every 1 aluminum bromide. Yes? Okay. So then, don't forget some basics about the periodic table that we talked about in the previous chapter, right? That we should be able to look at the table and know the common charges of things, right? These are always going to be +1, +2, right? -1, a -2, these are going to be -3, right? This is going to be +3, +2, +1, okay? Going back to last chapter. So those are things that we already know and you have to hold on to. Otherwise, you can't do this chapter, all right? So, moving along. This is one of the cool figures from your book about ways to represent a formula for methane, right? This is the formula we're going to work with for all of this chapter. This is the formula you guys are going to learn how to draw when we get to chapter 10, right? These are just different ways to represent this formula, right? As in, this just tells us about connections, right? What atoms are connected to what. These tell us about three-dimensional distribution, right? Which we don't get here necessarily, okay? Next up, types of elements and types of compounds. So previously we stopped here. We said that pure substances can be either elements or compounds. Now we're going to further define those, right? As in, elements can be atomic, where atoms mean singular particles make up that sample, right? Or they can be molecular, right? These are the only molecular elements that you are responsible for knowing, right? Specifically, these are diatomics. Okay. There are some other molecular elements that have more complicated formulas, which you're not required to know, right? So we're just going to stay here, and these are the molecular elements that you are required to know, okay? If we go to the compounds, right, can be either molecular or ionic, right? Where molecular is going to be two or more nonmetals chemically combined, right? And ionic compounds are going to be specifically a metal plus nonmetal, or it can be some combination of polyatomic ions, okay? So anyway, we can further differentiate our elements and our compounds at this point, okay? So again, molecular compounds will be composed of two or more nonmetals. Ionic compounds will be composed of a metal and a nonmetal, because those make up our cations and anions respectively, right? Or some combination of metal and polyatomic ion, or multiple polyatomic ions, depending on what we're talking about, okay? All right, now, before we start writing formulas, you do need to know your polyatomic ions. So this is just a list of common ones, like this table says, right? There are far more than what's listed here. This is just where we start, because, you know, we got to start somewhere. All right, so a couple things to note. The vast majority of these are anions. This is the only cation. All right, everybody else here is an anion. And the vast majority are oxyanions. What does that mean? Right, it contains something plus oxygen, right? So that's the majority of them. Note that the order in which they are written is the order in which you should write them, right? So hydroxide is written as OH, so you will not write it HO, okay? These are not fractions, okay? This is the charge, and this is a subscript, right? As in acetate is C2H3O2 is the formula, and that formula for acetate has a charge of -1. Yes? Okay. Moving along, there are some trends that present themselves here, right? Where if we know the chlorate ion is ClO3, chlorite, what do we notice? Right. Charge is the same. General formula is the same. There is just one less oxygen. Yes? And hypochlorite means one less oxygen than the ite version, right? Perchlorate means one more oxygen than the ate version. Yes? So what that means to me is if I know the ate version of something, then I know everything else by extension, right? If I know the ate version, then I know everything else by extension. Sulfite is going to be one less oxygen. Yes? Does that make sense? Okay. Another observation, right? When we take something like sulfite, which is SO3 2-, and we add a hydrogen to the front of it, if we go back, we know that hydrogen, being up here, has a charge of +1, right? Now, it's not a metal, right? So it's hard to imagine it behaving like a metal, which is, you know, being a cation, but it behaves much the same way. So if we think about hydrogens as having +1 charge, when I add an H in front of this HSO3, what do you notice happens to the charge? Right, it's like we added 1 to it. Oh my gosh. Or hydrogen sulfate, it's like we added 1 to my sulfate, yes? All right, trends that present themselves. All right. How to write formulas for ionic compounds. This is section 5.6, things that are assumed knowledge. That you know the common charges, right? And you know your polyatomic ions. Obviously, you don't know them just yet, but that's something you need to work on memorizing, and kind of like with the element names and symbols, you have to know them as well as you know your first name. Otherwise, you know. All right, goal. So your book gives you a little shortcut way to do it, right? We are going to do it this way because this means that we have reasoned through it a little bit better, and it's going to help us when we get to writing the names if we do it this way, all right? So this is going to be our goal, is that the amount of positive charge must cancel the amount of negative charge. So if I'm going to write a formula for sodium and sulfate, the compound that they make, first I'm going to figure out what their formulas and charges are, right? So I know that sodium is Na, and based on my periodic table, I know that it has a charge of +1 because it's in group 1. So Na, charge of +1. Sulfate, right, is right here, so that is SO4. Again, that's its formula, charge of 2-, right? So I need to make the amount of positive charge cancel the amount of negative charge. So if this is a +1, this is a -2, really all this is an exercise in what is the lowest common multiple, right? That's what we're saying. If we want the amount of positive charge, so the magnitude of positive has to equal the magnitude of negative, we're looking for the lowest common multiple, right? So what that says to me is I'm going to need 2 of these, right? And I'm going to need 1 of these, right? Does that make sense? Right? Which also matches what your book says about dropping the subscripts, okay? Or dropping the superscripts. So my formula is going to be Na2SO4, right? Which says I have 2 sodiums for every 1 sulfate, yes? And if I work that out, right, 2 times +1 equals 1 times -2, and indeed, the amount of positive charge equals the amount of negative charge, right? So we probably did it right. Okay, next up, aluminum and chlorine. Let's take this over here. Aluminum, if we go back and look at our periodic table, charge of, right, 3+. Chlorine has a charge of, right, -1, right? So again, lowest common multiple is 3. So that means I need 3 of these, 1 of these. My formula is going to be AlCl3, right? And if I want to double check, right, I have 1 aluminum with a charge of +3. I have 3 chlorines with a charge of -1. The amount of positive cancels the amount of negative. Okay? Next up, barium and perchlorate. So barium, charge of, right, perchlorate, what is that? Right, ClO4 -1. So again, lowest common multiple is 2. So I need 1 of these, 2 of these. So Ba, now ClO4, 2. Because I need to indicate that I need 2 of this whole ion, okay? Because it behaves as its own entity, right? ClO4 is like its own thing, right? 4 is like part of its name. It's like the E at the end of rose, for example, right? It's there, it's a part of the name, so it always goes with it, right? So the only way to indicate that I need more than 1 would be to put parentheses and then my subscript, okay? All right, next up, we've got our K and Cn, right? So K has a charge of +, Cn has a charge of -1. Oh, look, this one is so easy, right? Obviously just 1 of each. Next up, we have calcium and CO3, so calcium 2+, CO3 2-, again, 1 of each. And so here is where you have to be really familiar with your polyatomic ions, because otherwise you might be confused and say, oh, this is a calcium plus a carbon plus 3 oxygens. No, this is a calcium and a carbonate, right? So again, that's the importance of knowing your polyatomic ions, because obviously eventually, right, next section, you're going to figure out how to put names to these formulas, and that's going to be very hard if you don't know your polyatomic ions well enough to recognize them on site, okay? And last up, we have our Ca and HCO3, so Ca 2+, right, HCO3 minus, so that means I need 2 of these, 1 of these, calcium, oops, I don't know why I put that big space, 2. Yes, makes sense? All right, practice, practice, no worries, we will do more practice next period, obviously. All right, thank you for listening, be good, and I will see you soon. Bye.